Practice number 2 worksheet. We're given some data, and we wish to practice with the functions average, median, and standard deviation, and also later a 5-number summary. Understand the data. We have 5 columns, 12 rows of data. Each month of the year, we have the temperature, the average monthly temperature for 5 years. The average or the mean in the month of January for these 5 years. Average, the average function, select the 5 years, press enter, chop the decimal places. We have been asked for 1. Copy the formula down the column, and we have the average monthly temperatures. Similarly, we can compute the yearly monthly temperatures. In row 18, begin typing average. Select the correct function. Give it the 12 months of the year. Press enter. Chop the decimal places down. 27.5 is the average temperature for the year 2001. The median temperature for the year 2001. Select the function. Supply the data. Be careful not to also select the average temperature. The median temperature, if we chop the decimal places, 28.3. I may select both of these cells and copy the formulas across to all 5 years. The hottest year, if we base our observations on the average temperature, then the hottest year is 2003. We will note that this is the highest average temperature of the 5 years. Similarly, the coldest temperature, the lowest average temperature for the 5 years appears to be 2001, so that will be our answer for the coldest year, the lowest average temperature. Our answers would have been slightly different if we based our observations on the median temperature for each year. Practice with the 5-number summary. For the hottest year, we have declared the hottest year to be 2003. So the 5-number summary for the year 2003. The minimum temperature in 2003. Select the 12 months. The maximum temperature in 2003. Select the 12 months. Press enter. The median temperature in 2003, we actually have that. I can poke at that number and press enter. In the 5-number summary, this square is Q1. We want the first quartile of these temperatures. Q1. We use the quartile.exe, don't forget. We have to supply 2 things. Number 1, the data, and then with a comma, the number 1 to indicate the first quartile. For the 3rd quartile, we behave similarly. We begin typing the function QUA quartile.exe, supply the 12 pieces of data, 1 for each of the months, comma 3 for 3rd quartile, and press enter. It is asking us for 1 decimal place, so I may select all 5 numbers and chop the decimal places at the same time. And so we have finished the 5-number summary. The interquartile range, do not forget, is Q3. I can click on the value, subtract Q1. I can click on the value, the 3rd quartile minus the 1st quartile, the interquartile range, 11.2. And so, we're almost finished. At this point, we want the standard deviation. The standard deviation for January, the months of January in each of the 5 years. Begin typing the standard deviation function. This is the one we're looking for. Give it the 5 pieces of data. Press enter. And the standard deviation is a small number. This is not surprising. For example, the lowest standard deviation occurs in October, 0.4. That's the answer to question number 4, October. The average temperature in October is 30.4. And if you notice, the other 5 temperatures, we've taken the average of 5 temperatures, and these 5 temperatures do not differ very much from 30.4. 2 of them differ by only 0.1. One differs by 0.2. Another differs by 0.4. Another differs by 0.6. The average difference, 0.4. The standard deviation gives you the average variation from average, the average deviation from average. Very small, because in each month, for a particular month, the temperature is very close to the average. However, for the years, if I look in column B, row 20, if I find the standard deviation for the year 2001, we can expect that deviation to be a little bit higher. I will chop the decimal places. We get 5.5 as the standard deviation in the year 2001. The average temperature in the year 2001, 27.5. But there is variation over the months. In January, the average temperature, 18.4. In August, the average temperature, 35. We have some large variations from average. The average of the 12 months, 27.5. But 18.4 and 35, those are a couple of numbers that are quite a long way from the average. And therefore, we get a higher standard deviation. This is not surprising. Typically, the temperatures in the seasons vary. And so, which year had the highest variation in temperature? It looks to be 2005. The standard deviation was the largest. The standard deviation was the largest. However, in the month of October, always the temperature is the same in October. And so the standard deviation is the smallest. That's how we're basing. That is how we are basing our answer on the standard deviation. And that brings us to the end of practice number 2. I have written a solution. Why are the standard deviations less for the months than for the years? Of course, every year, given a particular month, temperature is always roughly the same. But over the 12 months of the year, you can expect a larger variation. There. The end of practice number 2.